Bismillahirrahmanirrahim and Assalamu alaikum students. As you all know, because of the pandemic situation, Guards Public Higher Secondary School has started online teaching. Your classes are now online lectures and videos. I'm Ms. Zareen Azim, your mathematics teacher. Very warm welcome in class 9th science group. Syllabus of first term, Unit 1, Sets, exercise number 1.2 and 1.3. Unit 2, System of real numbers, exponents and radicals, exercise number 2.2 till 2.4. Unit 4, Algebraic expressions, exercise number 4.2 till 4.4. Unit 5, Factorization, HCF, LCM, simplification and square root, exercise number 5.1 till 5.6. Unit 7, matrices, exercise number 7.1 till 7.3, and last Unit 11, fundamental concepts of geometry. In chapter number 1, sets, let's have revision. Well-defined collection of distinct objects is called a set. For example, collection of plates and dishes is called a dinner set, sofa set, sets of number, etc. The sets are denoted by capital letters. Members of a set are called elements, and elements can be object, small letters or numbers. These elements are always written inside curly brackets. Now types of sets. First type is finite set. A set consisting of countable number of elements is called a finite set. Here example, set A is equals to curly bracket 5, 7, 9, 11. Pay attention. Can you count how many digits are there? Yes, 1, 2, 3 and 4. Yes, there are 4 digits in this set, means you can easily count the digits. If you can easily count, they are countable, and such types of sets are called finite sets. Next type is infinite set. A set consisting of uncountable number of elements is called infinite set. Here the example is of natural numbers represented by capital N, and it is equals to curly bracket starting from 1, 2, 3, and here these dots represent that the set is onwards, means you cannot count how many digits are there in natural number. If you cannot count, that means it is uncountable set, and uncountable set is called infinite set. Third type is equal set. Two sets A and B consisting of the same elements are said to be equal sets. Means if you are having two sets and the digits which are present in first set also present in the second set, that means the two sets are equal. Next is null set or empty set. A null set or an empty set is a set with no member. It is denoted by empty curly bracket or a symbol phi. Means we can use these both notations to represent null set. Next is universal set. Any set which is a superset of all the sets under consideration is said to be universal set, and it is denoted by capital U. Means The universal set is the set which contains all the elements under consideration. Subset. A subset A is said to be subset of B if every element which belongs to A also belongs to B. Consider the example. Here set A is equals to 1, 2, 3 and set B is equals to 1, 2, 3 and 4. Look, the three members of set A, which are 1, 2, 3, are also the members of set B. It means A is a subset of B. Next type is proper subset. A set is said to be a proper subset of B if A is a subset of B, A is not equals to B, or A is a subset of B but B contains at least one element which does not belongs to A. Again consider the example of subset A which has the members 1, 2, 3 and B has the member 1, 2, 3, 4. Consider the digit 4 of set B. It is not present in set A. It means here A is also a proper subset of B because B contains at least one digit which is 4 and this 4 is not present in set A. It is also the example of proper subset. Next type is improper subset. A set A is called an improper subset of B if and only if A is equals to B. Every set is an improper subset of itself. Means if two sets are equal, then these two are called improper subset of each other. And every set is an improper subset of itself. Last is power set. Power set of a set is defined as a set of every possible subset. If the number of elements in set A is n, then number of power set is 2 exponent n. Some important sets of number. Set of natural number represented by capital N and it always starts from 1, 2, 3 and onwards. Set of whole number represented by capital W and starts from 0, 1, 2, 3, 4, 5 onwards. Set of integers represented by capital Z and it contains all the negative number, 0 and all the positive number. One thing to remember here, set of positive integer represented by Z positive and it contains all positive number means starting from positive 1, positive 2, positive 3, all positive number. And set of negative integer is represented by Z negative and it contains all negative digits means -1, -2, -3 all negative digits and set of integers contain all negative digits 0 and positive digit. Then we have set of prime number represented by capital P and it is equals to 2, 3, 5, 7. Set of odd number represented by capital O and members are 1, 3, 5, 7. Set of even number represented by capital E and members are 2, 4, 6, 8 onwards. Now set of rational number represented by capital Q and it is equals to X such that X is equals to P over Q. What are P over Q here? They are variables which represent that any number that can be written in the form of numerator and denominator, means it contains digits which are in the form of p over q, means in the form of fractional form. Set of irrational number represented by q prime, and these are the members x such that x is not equals to p over q. The members which cannot written in the form p over q or that cannot be written in fractional form are called irrational number. Last is set of real number. Union of rational and irrational number is called real number. Real numbers are represented by capital R, and it contains all rational number and all irrational numbers. Operation on two sets. First we will learn union of two sets, then intersection of two sets, difference of two sets, symmetric difference of two sets, and then complement of a set. Union of two sets. The union of two sets is denoted by A union B. Here we use sign of union, which is capital U. It contains all the elements of two sets without repetition. For example, let A is equals to F, A, C, E, and B is equals to E, D, G, F. Question is to find A union B. Next step, list members. In place of A, write down its set F, A, C, E union with E, D, G, F. The union is write down all the numbers without repetition. I have mentioned here A, C, D, E. Pay attention. Member E is present in set A and in set B, but in the union it is written only once, not two times. Similarly, F is present in set A and B, but in union we will write it down only one time, and then G, means union contains all the digits of two sets without repetition. Intersection of two sets. Intersection of two sets is denoted by A intersection B. The sign which we use for intersection is opposite of U. It contains the common elements of the set. For example, let A is equals to F, A, C, E, and set B is equals to E, D, G, F. For A intersection B, list members of set A, then intersection member of set B, and the common members which are present in set A and set B are only E and F. Therefore, the intersection is E, F, and this is the answer. Difference of two sets. It is denoted by A minus B. It contains the members which are present in first set but not present in the second set. Consider the example. Set A is equals to 1, 2, 3, 4, and set B is equals to 2, 4, 6 and 8. For finding A minus B, first list the members of set A, which are 1, 2, 3, 4. Then difference, list the members of set B, which are 2, 4, 6, 8. And the answer A minus B is equals to 1 and 3 because members 2 and 4 are also present in set B. And in difference, we will mention only those digits or only those members which are present in first set but not present in the second set. Since 2 and 4 are also present in second set, therefore we will write only 1 and 3 in the answer. Symmetric difference. It is denoted by A. Symmetric difference. B. Normally we use the sign of triangle, which is also called delta, for symmetric difference. It contains non-common members of two sets. There is a formula for finding asymmetric difference B, and it is equals to A union B minus A intersection B. Consider the example. Let A is equals to 1, 2, 3, 4 and B is equals to 2, 4, 6, 8. For finding asymmetric difference B, first list the members of set A with the sign of symmetric difference and then members of set B. Now asymmetric difference B, we will write non-common members of two sets. First tell me what are the common members. Yes, 2 and 4 are the common members. And for writing symmetric difference, we do not write common members. We write non-common members. It means in answer we do not write 2 and 4. Then remaining non-common members are 1, 3, 6 and 8. Now this is the answer of symmetric difference. Complement of a set, it is denoted by A complement. We write capital A and a comma on its top. It is defined as the difference from the universal set. The formula for finding A complement is equals to universal set minus A. Universal set contains all the elements under consideration. Consider the example here. Let U means universal set is equals to 1, 2, 3, 4, 5, 6 and 7 and set A is equals to 2, 4, 6, 8. A complement is equals to universal set minus A. Then again write down A complement is equals to, first list all the members of universal set minus the members of set A. Since it is a simply difference, and when we find difference, we write the members which are present in first set but not present in the second set. Means 2, 4, 6, 8, which are the members of set A. We do not write 2, 4, 6, 8 and we write all the remaining members of universal set. Means A complement is equals to 1, 3, 5, 7, 9 and 10. Now this is the answer of A complement. Exercise number 1.2. Given that the sets A is equals to F, A, C, E and B is equals to E, G, D, F are the subset of the universal set U is equals to A, B, C, D, E, F, G. List the elements of B complement. It is the question number 2 in exercise number 1.2. As you all know, complement means difference from universal set. A complement means difference of set A from universal set. What will be the meaning of B complement? Yes, Think. Yes, B complement means difference of set B from universal set. After solution, write down the formula. B complement is equals to universal set minus B. Next step, B complement is equals to list all the members of universal set minus all the members of set B. And whenever we find difference, we write members of first set which are not present in second set. Means in answer, we do not write E, G, D, F which are the members of set B. We will write only the remaining members of universal set which are not the members of set B. Means in answer, we will write B complement is equals to A, B and C. Exercise number 1.2 and question number 5 is A intersection B complement. After solution, first find B complement, and B complement means difference of set B from universal set. We have found B complement in question number 2. So I am directly using the result of B complement which is equals to A, B, C. Next step, A intersection B complement is equals to list all the members of set A which are F, A, C, E, intersection with members of B complement which are A, B, C. Now intersection means common members. Can you tell me which members are in common? Yes. Yes, A and C. Therefore, we will write A intersection B complement is equals to A, C, and this is the required answer. Exercise number 1.2 and question number 7 is universal set union phi. Phi is the representation for the null set. First U stands for universal set and second U represent the operation between these two sets which is union. That means required is universal set union null set. Now we are going to find union of universal set and null set. After solution, mention universal set union phi is equals to list all the members of universal set and union with null set. Null set are normally represented by phi and empty curly bracket, means curly bracket without any member. Union means write down all the members between two sets. Here second set contain no any member, means null set contain no member. All the members are in universal set. Therefore, the answer for the union between universal set and null set is equals to A, B, C, D, E, F, G. Or also you can say that union of universal set and null set equals to universal set. Next question, question number 8 is universal set then intersection with phi. Here required is the intersection of universal set and null set. Again after solution, list all the members. Universal set intersection null set is equals to all members of universal set with a sign of intersection, and then null set means set without any member. Now tell me students, what is common between these two sets? Because null set contain no any member, therefore No member is common in between these two sets. So what should be the answer? Yes, answer should be a null set because there is no common member between universal set and null set. Therefore, the answer for the universal set intersection null set is also a null set. Exercise number 1.2 and next question is given that the sets A is equals to curly bracket x such that x is a positive even integer less than 10 and B is equals to curly bracket x such that x is a positive odd integer less than 10 are subset of the universal set U is equals to curly bracket x such that x is a positive integer less than 10 curly bracket close. List the elements of A union B complement. It is the question number 9 in your book. Here in this question, sets are given in set builder notation. First, convert these sets in tabular form, and in tabular form, set A, which is defined as positive even integer less than 10. List the members. Tell me positive even integer less than 10. Positive integers starts from 1 and even integers starts from 2. Yes, because 1 is not even number. It is the odd number. So, even integers less than 10 means write down 2. Then next even number 4, 6 and 8. What about 10? We are not going to write down 10 here because in set builder form it is very clearly defined that positive even integer should be less than 10. That means we will not consider the digit 10. We will write only 2, 4, 6 and 8. Set B is positive odd integers less than 10. Now positive odd integers, positive numbers starts from 1 and odd number starts from 1, 3, 5, 7 and 9. Now the last universal set is all positive integers less than 10. Means we will mention all the numbers starting from 1 till 9 in universal set. Required is A union B complement. So first we will have to find out B complement here. B complement means simply the difference of set B from universal set. Mention B complement is equals to U minus B. And then again B complement is equals to list all the members of universal set minus all the members of set B. Difference mean mention the remaining members of first set and do not mention the members which are present in second set. Means the set B contains 1, 3, 5, 7, 9. So we will not write 1, 3, 5, 7, 9 in the answer. We will mention only B complement is equals to 2, 4, 6 and 8. This is the answer of B complement. But the question is A union B complement. Now you will have to find out the union of set A with B complement. List all the members of set A which are 2, 4, 6, 8 union with B complement, and look here B complement is also equals to 2, 4, 6 and 8. A union B complement. First tell me meaning of union. Union means unite or write down all the members between two sets without repetition. If digit 2 is present in first set, that means in A, and it is also present in the set B complement, but we will write it down only one time, not two times. Similarly, 4 will be written only one time, 6 one time and 8 one time. We will not write them down two times. It means the answer of A union B complement is equals to 2, 4, 6 and 8. Pay attention here, this set 2, 4, 6, 8 is equals to set A. Yes, in tabular form it is mentioned that this is equals to set A. So finally I can write A union B complement is also equals to set A, and this is the required answer. Exercise number 1.2 and question number 10 is A complement intersection B. After solution, first mention all the sets which were given in the question in set builder notation, and we have converted them into tabular form. Set A contains positive even integer less than 10. Set B is equals to positive odd integers less than 10, and universal set is all positive integers less than 10. As in the question, required is A complement intersection B. So first we will have to find out A complement. A complement is equals to difference of set A from universal set. Next step, A complement is equals to list all the members of universal set, then minus and all the members of set A. In difference, we will mention remaining members of the universal set which are not present in set A. Means in answer we are not going to write 2, 4, 6, 8. We will write A complement is equals to 1, 3, 5, 7, 9. This is the answer of A complement. Now next, what is required in the question? It is required to find out intersection of this A complement with B. Write down A complement intersection B is equals to list all the members of set A complement which are 1, 3, 5, 7, 9 intersection with set B, and members of set B are 1, 3, 5, 7, 9. Intersection means the common members between these two sets, and here the two equal sets are given. So intersection is equals to 1, 3, 5, 7, 9 because all digits are common in between these two sets. And A complement intersection B is equals to 1, 3, 5, 7, 9. If you pay attention in tabular form, this 1, 3, 5, 7, 9 is equals to set B. Finally, we can write A complement intersection with B is also equals to set B, and this is the required answer. Exercise number 1.2, question number 12 is A symmetric difference B. First, write down the sets in tabular form. A is a set of even numbers less than 10 and members are 2, 4, 6, 8, and B is the set of odd integers less than 10 and members are 1, 3, 5, 7, 9. Next step, A symmetric difference B is equals to first list all the members of set A, then with the sign of symmetric difference, and then the members of set B. Pay attention here, in symmetric difference we do not write common members, we only write non-common members of the two sets. Can you tell me any member in common between these two sets? If you pay attention here, set A is a set of even numbers 2, 4, 6, 8, and set B is the set of odd numbers, that is 1, 3, 5, 7, 9. Clearly there is no member in common and all the members are uncommon. So we will have to write down all the members of first set and all the members of second set in the answer of symmetric difference, because in symmetric difference we write non-common members of the two sets. Finally, instead of writing 2468 and then 13579, it is better to write the numbers in sequence so that you will not miss any number. I am writing A symmetric difference B is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and these are the positive integers less than 10 and it is universal set. So in the answer I am writing A symmetric difference B is equals to capital U, which means it is a universal set and it is the required answer. Now consider question number 14. Here also symmetric difference is required, but in between A complement and B. Question is A complement, symmetric difference B. After solution, list members. First find A complement, and since we have found A complement in question number 10, slide number 17, therefore I am directly using the result of A complement, which is equals to 1, 3, 5, 7, 9. Or it means simply the difference of A from universal set, and members of set B are 1, 3, 5, 7, 9, which is the set of odd integers less than 10. For finding symmetric difference, write down A complement, symmetric difference B is equals to, list all the members of A complement, then with the sign of symmetric difference and all the members of set B. In symmetric difference, we do not write common members. We only mention non-common members of the two sets. But if you pay attention here, all the members of set A complement are common to the all members of set B. It means there is no any single member uncommon or non-common. Therefore, A complement intersection B is equals to a null set because there is no any single non-common members between these two sets. Or finally, I am writing in the answer A complement symmetric difference B is equals to 5, which is the representation for the null set and it is the required answer. Key points: union means unite or write all members of two sets without repetition. Intersection means write only common members of two sets. Difference means write non-common members of first set only. And symmetric difference means write non-common members of two sets. Indifference, non-common members of first set only. And in symmetric difference, non-common members of two sets are required. And for complement, take difference from universal set, means write down non-common members of universal set in the answer of complement. Review of today's lecture. Today we have done different types of sets. For example, finite set, infinite set, equal set, null set, universal set, subset, proper subset, improper subset and power set. And we have also covered operation on two sets like union, intersection, difference, symmetric difference and complement. In exercise number 1.2, we have covered question number 2, 5, 7, 8, 9, 10, 12 and 14. Thank you students for watching. Keep practicing on separate sheets. I know at home there is a lot of potential of distraction, but to concentrate on schoolwork, set aside a workspace and create a study schedule because maths need practice a lot. After completing exercise number 1.2 and 1.3, I will give you home assignment. Allah Hafiz.